last lecture, we have looked at various time complexities, but we need to take into account that time is not only the thing that matters in an algorithm. We might also care about the amount of memory or space that is required by the algorithm. It's a parallel concept to the time complexity. Space complexity is a measure of amount of working storage an algorithm needs. That means how much memory in the worst case is needed at any point in the algorithm. As with the time complexity, here also we mostly concerned with how the space that is needed grows as the size of input grows. If we create an array size of n, the space complexity will be O(n). If we need a two-dimensional array size of n by n, the space complexity will be O(n squared). So let's look at the following example. So here we have a block of coding which is summing up the number from a given number till 0 by calling itself recursively. So the method like this, which are calling themselves recursively, count in the stack memory. So each call adds a level to the stack. So each call that are added to the stack takes an actual space in the memory. This means we need O(n) memory for this block of code over here. So if we call this function for n equals 0, we see that each call is added to the stack memory. So it means it takes a memory in the stack. So as the input size grows, the memory that we need will grow also. It depends on the size of the parameter that we are inserting over here. Because in every call, we have to remember the previous call to come back to it. That's why it needs to be added to stack memory. So we have explained this case in our recursion section. So if you don't know how the function is added to stack when we are calling it recursively, I advise you to go back to the recursion section and watch this part of the lectures. So in this case, for this block of code, we need O(n) space complexity. On the other hand, there are some cases that n calls do not take O(n) space complexity. It means not all cases of n calls require O(n) space complexity. Now, for example, in this case, we are calling pair sum function inside pair sum sequence function n times. But in this case, the space complexity is O(1) because we don't have to remember the previous call to come back to it. So that's why in this case, the space complexity will be O(1). Okay, with this short lecture, I have tried to explain that the time complexity is not only concerned about the algorithm, so we need to take into account space complexity. So the time is not only the concern in algorithmic performance. So we need to take into account space complexity as well.